In this video, we're going to be taking a look at factor trees, and the goal for today is to be able to create or find factor numbers using a factor tree. The essential question that we want to unlock or to answer is, how can you find factor numbers using a factor tree? So the first thing we are going to do is turn to page 249 in your math book, and we are going to unlock this problem. Okay, so right at the beginning, it has Mr. Shu gives this puzzle to his math students, and what it says write 24 as a product of factors that are prime. Remember that a prime number must be greater than 1 and can only have 1 in itself as factors. So that is important to understand. Whenever we're creating a factor tree, you know you're finished when you just have prime numbers. Okay, you can use a diagram called a factor tree, and that's what we're going to take a look at to find the factors of a number. Okay, so for step number 1, what we want to do first of all is we want to write the number at the top, the number 24 right at the very top. Okay, then from here, step 2, we want to write it as a product of any two factors. It could be 2 and 12, 3 and 8. Okay, but what we will do, we're going to use 4 and 6. So we're going to break each of these down so we just have all just prime numbers. Okay, now step 3, write each factor as a product of two factors. So 4 is a product of 2 times 2. 6 is a product of 2 times 3. Okay, now what we can do for step 4 is continue until each factor is a prime number. Okay, we could not break 2 down any further or 3 down any further. So then we want to do is write the factors that are prime numbers from least to greatest. Let's do that. Even though we already have it here, we'll rewrite it again. 2 times 2 times 2 times 3. Okay, so we know that 24 equals 2 times 2 times 2 times 3. In other words, when you multiply all these numbers together, it'll still give you 24. Now let's all turn to page 250. I want you to take a look at number 1, and we'll do this problem together. Okay, so it says use a factor tree to find the prime number factors that have a product of 210. So the first thing we will do is just write 210 at the top. Okay, now they already have 21 for us, so we need to think about, or if we were to do this, we could think about any two numbers multiplied together that gives us 210. We could have 70 and 3. We can have 105 times 2. But for this, we have 21 times 10. You can start out any way that you would like, but you need to finish with just prime numbers. Okay? So we have 10 and 21. So we can break 10 down. Okay, so first of all, write 21 as a product of any two factors. We have 210 equals 10 times 21. Okay, so we're going to break 10 down, which is 2 times 5, 21 down, which is 3 times 7. Okay, so what we have here, the factors, we have 2 and 5, 21 is 3 and 7. Okay, now from here, now each factor only has 1 in itself as factors. 2 times nothing else other than 1 equals 2. 5 times nothing else other than 1 equals 5. And it's the same for 3 and 7 as well. So now what we want to do is we want to just write these in order from least to greatest. So we have 210 equals 2 times 3 times 5 times 7. Okay, let's take a look at number 2. And what we can do first of all is we're going to use the factor tree to find the prime number factors. Okay, so we can start out with 4 times 2 for our first step. Okay, then from here we cannot break 2 down anymore, so we're just going to break 4 down. 2 times 2. We will drop the multiplication sign. We'll drop the 2 that we did not use. Okay, and then we can see the prime number factors for number 8. 2 times 2 times 2 equals 8. Now there's a way to check this if you want to get your calculator out. Just multiply all these prime numbers together and it has to give you the number that you started out with. Okay, let's take a look at number 4. How have you do number 3 all by yourself? Let's take a look at number 4. We have 350. So we can start out with any two numbers multiplied together that equal 350. We could start out with 35 times 10. We could start out with 175 times 2. So anything that you would like to start out with, as long as you get to the prime number factors, that's the important part. Okay, so I will start out with 35 times 10, and let's do this together. Okay, now from here, we're going to break down my 35. I know 7 times 5 equals 35. I'm drop down my multiplication sign, and for 10, I know 2 times 5 equals 10. Now, there's not any other number other than 1 you can multiply by to get to 7. Same with 5, same with 2, same with 5 again. So these are all prime numbers. Okay. Now we know all these numbers are prime, but if we want to check it, what we could do, we could just multiply 7 times 5 times 2 times 5, and that gives me 350, and that's the number I started with. Okay, so what I will do now is write these from least to greatest. I have 2 times 5 times 5 times 7. Now what I want you to do is number 3 all by yourself. Try to find the prime number factors for 45. When you press play, I will have the answers for you. So pause the video now. Okay, so we have the prime number factors of 45 is 3 times 3 times 5. Multiply these numbers together. They're all prime. They do equal 45. What I want you to do now is numbers 5, 6, and 7. If you're not clear on this, you can even rewind the video and watch some of the previous factor trees that we did together. However, if you feel comfortable, do numbers 5, 6, and 7. When you're finished with it, you can press play, and I have the answer for you. So pause the video now. Okay, so you can see the answers for 5, 6, and 7. Now, what we'll do is let's take a look at number 8. It says write 500 as a product of prime number factors. Each factor must be greater than 1 and can only have 1 in itself as factors. Okay, so what we need to do is we need to break down 500. Okay, so my first step, I need to think about what times what two numbers multiplied together gives me 500, and we can just start out with 10 and 5. I'm sorry, 10 and 50. So 10 and 50. I will change inks just so we can kind of keep everything straight. We can break 10 down to 2 times 5. We're going to bring down that multiplication sign. 50 can be broken down to 5 times 10. Okay, now we have all prime numbers except for the number 10. And let's break down 10. We have 2 times 5 here. Okay, so we can bring the 2 down, bring the multiplication sign down, bring my 5 down, bring the multiplication sign down, bring my other 5, bring the other multiplication sign down. So now we have 2 times 5 times 5 times 2 times 5. Okay, we do want to order this from least to greatest, so 2 times 2 times 5 times 5 times 5. Now if we want to double check this, we can get out our calculator here, which I highly suggest. Okay, we can just punch our numbers right in. We have 2 times 5 times, we have 2 times 2 times 5 times 5 times 5 gives me 500, so that means we do have the correct answer for my prime number factors of the number 500. Now, what I want you to do, let me move my calculator out here. I want you to do number 9. I want you to think about this. It says find a number that has 4 identical even factors. Okay, so a couple things that we need to remember is that they're identical, that they're even. Each factor must be greater than 1 and can only have 1 in itself as factors. In other words, they have to be prime numbers. So think about that, and I want you to try to figure it out. When you press play, I'll have the answer for you. So pause the video now. Okay, so we have one of the numbers here could be, or the number here is 16. Okay, so the thing that we need to remember is that they're 4 even factors. Okay, so 2 times 2 times 2 times 2 does equal 16. Now understand we can use a lot of, 3 times 3 times 3 times 3 and so on. Okay, but remember it has to be even. However, they do have to be prime, and 2 is actually the only even prime number, so the answer there is 16. So think about the essential question: how can you factor numbers using a factor tree? The answer to that is I can make a factor tree, choose a pair of factors of the number, continue factoring each factor until each resulting factor on the tree is greater than 1 and only has 1 in itself as factors or are prime. Okay, so this is how you use factor trees. And if you have any questions about this concept, please come and see me.